Welcome to section 4 of chapter 4. This is going to be our section where we're going to learn kind of the last bits of rules for doing derivatives and shortcuts for them. Here you see a list of different types of functions we've learned how to differentiate so far. And what we have left are exponential and logarithmic. So these first couple videos are going to focus on the exponential, the next few on the logarithmic. So with exponential, the easiest one for us to actually start with is e to the x. This is one of my favorite derivatives to do, mainly because when you do the derivative, you actually get e to the x again. And I'll show somewhere else, I'll post a separate proof of this just so that you can see where it comes from. I'm not going to do it here in the video, but it's important to remember the derivative of e to the x is e to the x. And we can use this in conjunction with our other rules as well. So here if I have the f of x equals e to the 4x, well, I'm going to be using the chain rule. So my derivative is going to be itself, e to the 4x, times the derivative of 4x, which is 4. If I have e to the negative 1/2 x, well, its derivative is going to be itself, e to the negative 1/2 x, times the derivative of negative 1/2 x, which is negative 1/2. Next, if I have 3 times e to the negative x squared plus x, well, its derivative is going to be 3 times e to that power, but then times the derivative of that power. And then here I have 7x times e to the negative 3x cubed plus x squared. I'm going to need to use my product rule on this, which is first times the derivative of the second, which is going to be e to that power, times the derivative of that power, then plus second, e to the negative 3x cubed plus x squared, times the derivative of the first part, which is 7. Next is looking at what happens if e is not the base. So we still have x in the exponent, hence the name exponential, but e is no longer the base. And what we do here is we work with the fact that we can change a to the x to b with base e. And what it is if you remember e and natural log cancel each other out, so if we raise e to the natural log of a to the x, the e and the natural log would cancel out and take us back to a to the x, but using a property of logarithms, I can pull that x out in front of the natural log, and I have e to the x times natural log of a, and I can do the derivative of this as long as I remember that natural log of a is a constant. So the derivative of a to the x would be a to the x itself, because I'd have e to the x times natural log of a. Then using the chain rule, derivative of the power would be just natural log of a. So derivative of a to the x is a to the x times natural log of a. So if I have 4 to the 3x plus 2, well, the derivative of 4 to that exponent would be 4 to the 3x plus 2 times the natural log of the base, which is 4. And then doing the chain rule times the derivative of the power. Whoops, messed that up. That's going to be just times 3. If I have 8 to the x squared plus 1 power, well, derivative is my exponential times the natural log of the base times the derivative of the power. Same thing here with h of x. Derivative of an exponential is the exponential times the natural log of the base times the derivative of the power. So we can use this and start to look at some applications of it, one of which being here, where does the exponential y equals 2 to the x power minus 3 have a slope of 21? Well, this means that we're looking where my derivative is 21. So I need to find dy dx. So taking the derivative, well, 2 to the x, it's an exponential, so the derivative is the exponential, times the natural log of the base, and then the derivative of the power of the exponent is 1, then derivative of 3 is 0. And I need to know where is this equal 21. Well, that means I have 2 to the x equals 21 over the natural log of 2, whatever that decimal is. And then, if I want to, I can take the natural log of both sides, which would cause my x to move out in front here. So I had x times the natural log of 2 equals the natural log of whatever 21 over natural log 2 is. And so x would equal the natural log of 21 over natural log 2 all over natural log 2.